Hi friends, in this episode we will see some more important terminology starting in B and also answer for two questions as in the comment box. One is amine removal from wastewater and another is fuel gas turn down ratio. Amine removal from wastewater can be done by adding acid or caustic and passing through activated carbon bed. We'll see now. Organic amines and phenolic compounds normally will be present in wastewater in the process waste. It can be removed from a wastewater solution by treating with activated carbon at a pH of 5 or less. Phenolic compound can be removed, and other organic acid also can be removed. Whereas organic amines are removed by treating wastewater with activated carbon at a pH of 8 or more. You have to do sodium hydroxide or caustic lye. Also, tertiary treatment by RO, ultrafiltration or nanofiltration followed after RO, then membrane filtration can also remove amine of wastewater during a zero discharge. Wastewater amine removal is required if you use amine in boiler feed water in the deaerator outlet in the boilers. Also, amine is used in LNG plant in the AGRU to remove H2S and CO2. In the wastewater, you can have activated carbon bed. We can increase the pH more than 8, then treat the wastewater. Or we can see another important terminology in B, burner. Burner is an important device or equipment used in boilers or in furnace. Burner is a device which does not ignite a fuel, but it produces two individual flows, one of the fuel dust or air mixture or liquid fuel or gas and the other of air for ignition and active burning in the furnace space. So it helps to mix fuel and the air to the furnace to get active burning. In other words, burners are devices used to mix fuel and air to achieve controlled combustion while producing a specific flame and heat release pattern. Burners are arranged on the furnace walls to ensure as complete combustion of fuels in the furnace core as possible. Also, in other words, burners are the device used to mix fuel and air to achieve controlled combustion while producing a specific flame and heat release pattern. So, if it is a liquid fuel, atomization is required. Nozzle is used with atomization, either mechanical atomization or atomization with steam and atomization with air can be done. Also, air is supplied through burner for combustion or firing in the furnace. Now we can see about the burner sequence. Say we have a lot of our sequence of cycle is there left like firing interval, post purge, period of idle, pre purge, and return to firing. This will be available and it can be frequently used in indirect firing or in the modulation is not there in the burner. We can see about the answer for fuel gas turn-on ratio. The fuel gas turn-on ratio is the ratio of the maximum fuel input rate to the minimum fuel input rate of a modulating burner. Turn-on ratio for some direct gas-fired burners will be around 25:1. This means the burner can easily modulate as low as 4% without cycling off and move up to 100% of full fire. High burner turn-on ratio has the following benefits we can see in the next slide. So the turn-on ratio is 25:1 in the gas-fired burner. This sequence or cycle cannot be done regularly or frequently. So if you want to reduce the load, you can reduce to 4% on minimum load. and required no need to stop the boiler. This sequence of purging and other things can be avoided. Then when you require full load, then you can increase to 100% through the burner. Also in the modulating burner, the fuel gas turn on ratio plays a vital role. We'll see the other benefits in the next slide. Do not forget to subscribe and share it with your friends and colleagues. Put your like and comments in the comment box. We'll see the benefits in the next slide. Now I can see the benefits of the burner turnaround ratio. It will increase the energy efficiency, that is improved ability to respond to late change of the boiler by means of a fuel gas turnaround ratio. It enhances stability and control over water temperature, increased stability and control over steam pressure, improved reliability and reduced maintenance costs due to less wear and tear and failure caused by excessive stopping and sorting. Limited thermal shock to boiler and refractory. So in the modulating controlled burner, the turn down ratio is more like 20:1. Can reduce the load up to 4%, and then when required you can increase to 100%. So that will increase the efficiency, it will increase the reliability and reduce maintenance costs and wear and tear. Also, it will reduce the thermal shock to boiler and refractory due to frequent stopping and starting of the boilers. So burner is required in fuel gas firing. Turn round ratio is important one, and we can have based on the vendor supply or based on your requirement. Normally, it is if it is good, good burner, turn round ratio will be 20:1, and you can have this type of benefits. Now we can see another important terminology, blower. Blower is an enclosed fan in a force or induced or balanced rod furnace. Blower to provide the combustion air. Blower differs from fan and compressor. A fan moves large amount of gas or air with a low increase in pressure. Example, fan in our home. A blower is a machine used to move gas or air with moderate increase of pressure. A more powerful fan, by changing the angle of the blades, a blower will be able to push air in any direction. A compressor is a machine for raising gas or air to a higher level of pressure. Main difference between a blower and compressor is the pressure ratio. Compressor operated at high pressure ratio, whereas blower at low pressure ratio. Blowers are mainly used for flow of air, gas required for exhausting, aspirating, cooling, ventilating, conveying, like that, etc. It is commonly known as centrifugal fans in industries. We will see about the schematic diagram and the difference between fan and blower in the next slide. This is a schematic diagram of fan, and this is a schematic diagram of a blower. Now we can see the difference between fan and blowers. Fan has blades for functioning or rotation, whereas blower has impellers for rotation. Fan is an electrical device, whereas blower is a mechanical device. Normally, fan consumes less electricity, so current consumption and power consumption will be less, whereas blower consume more electricity. Fan gives medium airflow depending on the capacity, whereas blower gives better airflow than fan. More flow will be there. Fan has a lot of types: radial fans, industrial axial fans, and propeller type. There are two main types available in blowers: centrifugal and positive displacement blowers. The pressure ratio is from 1 to 1.11, whereas the pressure ratio for blower is little more, 1.11 to 1.2. This is the main difference between fan and blower. No need to confuse. Only fan are used in domestic purpose also. Blowers are used in industrial use. Do not forget to subscribe, share it with your friends and colleagues. Put your comment and likes in the comment box. Hope you might have understand the two important question asked by one of the subscribers and my friend in the comment box for amine removal from wastewater and another fuel gas turnaround ratio. Hope we'll see some more important terminology starting in B in the next episode. See you in the next episode. Thank you very much.